Hey everyone, and welcome to section 9.4. This is the first kind of application that we have of quadratic equations, and it's kind of, well, it's using math to do more math, so, it can be kind of an interesting thing. Let's say we have something that looks like this: x to the fourth minus 4x squared minus 5. Now, we can't use any of the quadratic stuff that we know about because this is not a quadratic equation. Its degree is 4, right? Remember, quadratic equations have degree 2. However, what you can do is notice that the first term is x squared squared, and the middle guy is just x squared. So we're going to try a change of variables. That is, we're going to let u be equal to x squared. So everywhere I see an x squared in my original equation, I'll replace it with a u. And so we end up with u squared minus 4u minus 5. Hey, if we were to just come across this equation out in the wild, we would say, oh, this is a quadratic equation in the variable u. So this is an example of something in quadratic form. That is, an equation which, upon a change of variables, becomes a quadratic equation is said to be an equation of quadratic form. So this original equation is of quadratic form. It's a quadratic-like equation, if you like. So let's go ahead and solve that. Basically, once we've made our substitution, we just treat it like it's a normal quadratic. How are we going to solve that? Well, let's try factoring. I see that I have a negative 5 and a minus 4, so, that would factor as u minus 5 times u plus 1 equals 0. And then I can use the zero product property. Now, normally we'd be done if we had started with a quadratic equation to begin with, but we aren't. We didn't. So now what we want to do is go back and say, since u was originally x squared, we really have that x squared is equal to 5, and x squared is equal to negative 1. And then we are going to use a square root property to determine what the actual solutions are for x. So for the first equation, we take the square root of both sides. We get that x is equal to plus or minus the square root of 5. For the second equation, when we take the square root of both sides, we'll have the square root of a negative number, which we know isn't a real number. So actually, we don't even need to worry about this guy. So our solutions are just plus or minus 5. So that's not too bad. Let's try it again. What we want to focus on is making the right kind of substitution that's going to make our lives easier. It's going to turn our equation here into a quadratic one. And let's see. I have something squared plus 6 times a something plus 8 equals 0. So I can let my variable u, which is kind of the standard pick for a substitution variable, let u equal x minus 5. Then that equation would turn into u squared plus 6u plus 8 equals 0. And let's see, how do I solve that? I can factor it. I can say u plus 4 times u plus 2, because I know 2 times 4 is 8, and then 4 plus 2 gives me 6, so that's all good. And just solve. And now at the end we go back to our original equation. And there we have it, x equals 1 and x equals 3. So notice that actually this is a quadratic equation, right? We could have FOILed out this first term and then distributed this 6 with the x minus 5 and simplified and then factored, and we would have arrived at the same answer. But this saves us a lot of work. Saves us from having to do that foiling and distributing. So that's kind of nice. You can use this method to cut corners a little bit if you can recognize a good substitution. All right, now here I have something with a radical in it, which is, maybe a little bit disturbing, but remember that when I square a radical, I just get x. Now, you might say, okay, well, what about absolute value signs? But, the original equation has a square root of x in it, so it's not going to make sense to consider any values of x less than 0 anyway. So x being greater than or equal to 0, this is all good. So what we want to do is now make our substitution to be square root of x. And then what we're left with is u squared minus 7u plus 12 equals 0. And hey, that guy factors too. We substitute back to get to our original variable. And so we have that the square root of x is equal to 3, and the square root of x is equal to 4. So that is to say that x is equal to 9, and x is equal to 16 are our two solutions. Okay, gross. We have now fraction exponents, which, more or less mean the same thing as a radical, but, it's still worth looking at. So let's remember that x to the 2/3 power is really x to the 1/3 power squared. Right? It's the cube root of x squared. So I can make my u equal to x to the 1/3 power, and then I can factor. Then I have to go back to x, so x to the 1/3 power is equal to -4, and x to the 1/3 power is equal to 6. So then I have to cube both sides to get x by itself. So the solutions are -64 and 216. All right, last up, in the case of a negative exponent, this is a little bit trickier, but still not too bad, because remember that x to the -2 is really x to the -1 squared. So that means I can use u equals x to the -1 as my substitution. And then I get 3u squared minus 7u plus 2 equals 0. All right, looks like I'll have to resort to my AC method. So let's do that on the side real quick. Okay, so 6 and 1 work. Alright, so we get that u is equal to 2/3, or that u is equal to 2. And then we go back to our original variable. So we'll have x to the -1 is equal to 2/3. X to the -1 is equal to 2. Remember that a negative exponent really just means reciprocal. So the reciprocal of 2/3 would be 3/2, and the reciprocal of 2 would be 1/2. And so, as you saw here, it doesn't have to be the case that it's going to factor super, super nicely like the first few examples. In general, once you make the substitution, you could use any tool that you know to solve the quadratic formula and then substitute back at the end. So it could be that you need the quadratic formula, you need to complete the square, or who knows what. So just be cautious of that. But otherwise, yeah, that's really about it. So once you know how to solve a quadratic equation, you can pretty much solve anything in quadratic form. Next up, we're going to look at, I guess, quote unquote, real life applications of quadratic equations. So stay tuned.